Thank you all for braving the weather to make it in here today. We have an excellent speaker. I'm very excited about the talk. So today I'd like to introduce Professor Jonathan Helm. He's the Thornton Associate Professor of Operations and Decision Technologies at the Indiana University Kelley School of Business. He's got several titles and lots of incredible accolades. Also the co-director for the Center of Business and Life Sciences there. And take it away.
Thank you. Meeting, I was just like, hey, let's chat. Let's get to know each other a little bit. And, well, now here I am. So I'm going to give a talk about something that maybe looks like it starts out with COVID, but I know everyone's like really tired probably of hearing COVID research, COVID talks, things like that. So it's not really about COVID. That's just where it started. It's also a talk about a different way for us academics, I think, to engage with community, to engage with industry. And it's kind of like the journey and the learning process that I've went through with IU Health System in terms of actually doing research that provides value, gets implemented, affects lives, and then on the back end figuring out how we can publish it. So that's where we're at. We have one paper out of this. We're trying to figure out how to publish our second one. But when we went into this, we didn't really have any idea if we were going to publish this at all. We thought probably not, because it just didn't seem like the typical academic theory that we do. But so we kind of reversed the process. We basically solved the problem. Then we went back and said, okay, how do we publish this? So Delta coverage is the title that actually IU Health gave to this project, which is kind of cool because like I didn't know that in hospitals they knew words like delta, and they knew that delta means change and stuff like that. They came up with this. So I was like, oh, that's a really cool name. So we call it Delta coverage, and I'm going to tell you a little bit about that. But let's start at the beginning. So this is the Indy Star. This is up here for Bob. So COVID breaks out. The governor of Indiana actually did a pretty good job, I think, during the whole COVID thing. Shut down all of the elective surgeries, right? And hospitals were losing, the larger hospitals in Indiana were losing a couple $1 million a day because of shutting down the surgeries, right? Now, one might ask themselves, was that necessary? Right? It was a good idea. Actually, I recommended it in a policy piece I wrote. I was like, well, the first thing you should do is just shut down the surgeries because that's how you can make room. But in Indiana's case, they probably didn't need to shut them down as early as they did, and they probably could have brought them back later. That's all operational modeling. You just have to figure out how much space you're going to need in your hospital and work around that, right? Here's some other things that happen. So travel nursing became a real big thing during COVID. Travel nursing is where they pay nurses a lot of money to go take a 12-week contract somewhere in the country. Call it travel because these are short-term contracts. The nurses can go anywhere they want in the country. But the problem is when everyone doesn't have enough supply, right? What's the problem? Well, travel nursing just increased the cost because you're taking it from one and giving it to another, and both of them don't have enough nurses, right? So then everyone's paying. So what happened at IU Health, for example, is their nurses would leave to get travel nursing contracts, which these nurses can make up to $300,000 a year doing travel nursing. A typical nurse makes about 80, 90, something like that. So they were getting their nurses pulled away by travel nursing companies in Pittsburgh and East Coast and Texas and whatnot. And then they had to pay travel nurses to come in, right? So they net, they were the same, but they were just paying a lot more. They also decided to get real creative. Right? This was one of the most inspiring things. I've been in healthcare for a long time. I like to say I've been doing it since I was 19, because I started working at GE Healthcare when I was in college, when I was 19 years old. Then I worked there after I graduated. Then I did my Ph.D. in healthcare operations. But this is one of the most inspiring things that I've seen the healthcare system ever do, is they got real creative during COVID. They started doing things that I didn't think they had the guts to do. Healthcare is, for those of you who don't know, it's a very, very conservative industry. It does not like change. It doesn't like anything new unless it's a new medical device. So for the fact that they actually were forced into becoming creative and adaptive, this was kind of one of the most exciting things I've seen in my career. Okay, so we actually had a meeting set up with IU Health on March 19th, 2020, to discuss research ideas. We were like, oh, let's start some research projects. This will be fun. First COVID patient shows up in Indianapolis on March 12th. I get a call on March 18th, and the Associate Chief Nursing Executive says, I know we wanted to talk about fun research, but let's talk about COVID. So March 19th meeting was hijacked and became, can you guys run the analytics for IU Health during COVID? Because no one else out there seems to know how to do it in Indiana. I'm not saying I'm the only person that knows how to do it, but the state was, and you'll see this in a minute, the state was putting together a forecasting model for COVID demand that was based on a 2006 CDC model of the flu. And so, of course, they forecasted that it was going to be over in May of 2020, because that's what the flu does. It goes up and it goes down. And that wasn't working very well for IU Health. So we put a team together. There's some of our team. I worked with my esteemed colleague, Peng-Yi Shi at Purdue. So we have this sort of Indiana consortium. The only other big one we left out was Notre Dame, but we didn't know anyone at Notre Dame. So it's not that we don't like them. We just didn't know anyone there. So it was IU, Purdue, and IU Health. So we had a bunch of students, as you can see. We had some master's students. We had a couple undergrads. We had myself and Peng-Yi sort of leading the academic side. From the IU Health side, there was Troy Tinsley, who was the head of Workforce Central, by which I mean he manages 9,000 nurses that IU Health has. And there was the Associate Chief Nursing Executive for Operations, who oversees their 16 operations of their 16 hospitals. Okay? So here it is, March. We came in and didn't know anything about COVID. In fact, I had actually, just before this meeting, I had built a prediction model for COVID just to prove to my wife that it wasn't going to be a big deal. So I went into MATLAB and I coded up this SIR model, and I was using I was just using whatever data I could find out on the internet. Turns out that data wasn't very good. My model was fine. The data was bad. So we built this. We built the first prototype of this basic forecasting model to predict patient demand in about a week and a half. I think there were about 3 nights I didn't sleep at all, and we had a huge team. All just came together at once. So that one went pretty well, and they started using it to make their strategic plans, their surge plans, things like that. Then comes June, things settle down. Now they did want to say, okay, we know it's coming back in October, help us predict how many travel nurses we need to hire so we can deal with flu and COVID, because we never had to deal with that before. But they also wanted to say, look, we've done some really cool things, and I'll tell you what it is in a minute, but They did some very cool operational things with how they use their nurses throughout the system. And they wanted to basically say, okay, we did this during COVID. This was an innovation. But now we want to do this actually permanently because it worked really well, right? And it basically involves moving nurses around the system like an internal travel nursing program. They don't like to use that word. Sometimes they use words to describe it to our fellow academics. But whenever, whenever the chief nursing executive hears me say that, she's like, we don't really like that term. We're not going to, I also called it nurse transshipment, and she's like, we prefer the term deployment. You know, so they don't like to feel like they are, that their nursing organization is somehow like an industrial system. So they were moving nurses around because what happened was, you know, Indianapolis, things spiked, and then they got totally overloaded. So they brought nurses in from West Lafayette, Bloomington, the other cities in Indiana where they had big hospitals to deal with the surge there. Then as the cases in the city sort of tapered off, they started spiking in the more rural communities like my hometown of Bloomington, although I did call it urban, didn't I? I said it's more urban than Lafayette. It's 60,000 people, okay? It's not that big. And so then they started moving their nurses to basically to match the demand. And they liked this idea, and they said, you know, we want to do this as like a full-time program, but we can't do it like we did in COVID, because people were willing to move like at the drop of a hat during COVID because we all knew it was COVID. We were like, we knew we had to like step up. They're IU Health Heroes. They have these little hearts that they put in everyone's yard that says IU Health Hero. I've got one because my wife's a nurse at IU Health. But they said, well, you know, we like this, but we have to make it good for the nurses who are traveling around. So that's what we did. We assembled a team. So it was a slightly different team than the COVID team, but many of the same parts, and started working on it. We had a kickoff meeting in June at IU Health where the IU Health executives came in, and we created a whole plan for this thing. Now, of course, you can guess we created a plan for this thing. How do you think it went? Did it go according to plan? Absolutely not. We did finish when we said we were going to finish, but nothing went as planned. So, March 2021, we start thinking about, okay, if we are going to move nurses around, one, we have to give them advance notice, right? We can't call them up at 5 in the morning and say, hey, go drive 2 hours to your shift and work a 12-hour shift, then drive home, right? That's not cool. Can't do that. So we knew we had to give them some advance warning, 24, 48 hours. We also knew that we didn't want to call them just 24 hours ahead and say, hey, go drive 2 hours, right? So we developed like basically an on-call list that says you might be moving. You might be going from Indianapolis to Lafayette or Indianapolis to Bloomington 2 weeks from now. We'll let you know 24 to 48 hours if you actually go or not. And this kind of like made sense to them. They were like, you know, that's good. They can prep, you know, knowing that they might have to travel. They can, you know, get a babysitter or make sure that, you know, dog's fed or whatever, right? And then we just call them in or we don't. And the medical field's really pretty used to that sort of thing. Because their doctors are on call. Why not the nurses, right? Okay. So, you can see how long this took, right? This is like the longest. That's why I haven't published very much recently. This took a really long time. So in June 2021, we were in the process of tweaking, modifying, designing, and then like right in the middle of that, we found out that their data was not telling us what we thought it was telling us. First of all, IU Health has no way of telling how many patients they have in each of their hospitals. We had to actually calculate that ourselves from what's called the location history, which just says where every patient is at every point in time. So we did that, and then we realized that basically the numbers we were getting were way bigger than what reason should tell us. Turns out that their data was based on billing. And so sometimes they would bill patients at 2 different locations at the same time. But the patient obviously physically was not in those two different locations at the same time. So you'd see a patient in a PACU and a med-surg bed at the same time. So we were getting double counting. That set us back a couple months. Finding that, figuring it out, and fixing it. Then eventually, we got approval from the higher ups, the powers that be. There was a lot of missteps along the way where people tried to shut us down. In the nursing ward, they called it going rogue because they were doing something without official approval from the high ups. Some of them found out, didn't like it. Half of our team was removed from having access to data when they had already agreed to give us access to data. I was left with at the end, I was like myself and two of our students that were doing internships at IU Health were the only ones that could access their data at the end of the day. They just kept removing our data privileges. So I was going back to doing a lot of coding. And as an associate professor, you don't feel like, one, I'm not that good at coding anymore. Two, I don't feel like that's the best use of my time at this point. But I did it. So I did do a lot of coding. So here's IU Health. They're the biggest hospital system in Indiana. I think they make about, it's going to make them seem evil, but they make about $1 billion a year in revenue. They're one of the highest profit margin hospitals in the country. But they're also very good to their patients. So they have 1.4 million patients, 16 hospitals. And so this is the structure that we're working with. As you can see, we've got Paoli. I mean, it spans the whole state, right? You know, Indiana's a very long state. So we've got Paoli Hospital all the way down here and White Hospital almost up near Lake County, Chicago area. And so that's what they're dealing with. And they're trying to manage these stochastic fluctuations in occupancy across all their hospitals by moving a couple nurses around, having a couple flexible nurses that can move around between systems. So we came up with, here's our first mathematical notation. We came up with this idea, which is actually a really old idea in our field in industrial operations engineering, just transshipment. It's inventory, right? Nurses, again, they don't like to be called inventory, but it's like an inventory model, right? So basically what we have is we have like a two-stage stochastic program. Right? In the first stage, we put people on call. We say, okay, my first stage decision is 14 days to 21 days out, I'm going to decide who to put on call to move from one region to another, right? And then I have a recourse decision, which is the day of, I decide who actually to deploy, right? Because it's much cheaper to put someone on call and call them back than it is to call them 24 hours in advance and say, hey, by the way, can you go from down here to up here tomorrow? That'd be cool, right? So that's basically the framework, is we have this stochastic program that gives us those two decisions. It's really nice that we have this classical optimization model that fits exactly the framework that they were looking for. Right? It kind of just fell out that way. We're like, wait, this sounds like a stochastic program. And again, this is why I was at first I was like, I don't know if we can even publish this, because stochastic program's been around since the dawn of time. So people aren't going to be super impressed by my theoretical oomph by making a stochastic program to transship nurses, right? Okay, so here are the needs. We need prediction, right? Can't do stochastic programming without predicting. Right? So we need a prediction model that can do a really good short-term prediction, 24, 48 hours, and a decent medium-term prediction, 14 to 21 days. The interesting thing about hospitals is, if you know something about your hospital today, you can predict tomorrow pretty well, because most of the patients in the hospital tomorrow were in the hospital today, right? But if you go 14 days out, almost none of the patients that are in the hospital today are in the hospital 14 days from now, right? So two completely different prediction approaches. One, you can use current information. The other one, not so much. And then we need this decision support, which I already gave it away. It's a stochastic program. I coded it up in MATLAB and then found out that IU Health doesn't have a MATLAB license. So we had to recode it in Python. And I'll tell you, Python is not as fast as MATLAB in the optimization. At least it definitely did not run as fast when we recoded it. Or it could have been my fault because I don't know Python that well. I'm a MATLAB guy, but then I realized no one uses MATLAB, just us academics. Okay, so here's the basis of the forecast model. And this, Bob was asking me, like, how different was the final model from the one we built in a week and a half? And I got to tell you, or how much better did it work? I got to tell you, it didn't work that much better. Like, it worked better, but not that much. I mean, the majority is just getting the model in there in the first place. And then you push the limits to see just how good you can get. But it's all based on this very simple patient flow concept. So for those of you in healthcare, have a pretty good idea of how patient flow works. If not, I will walk you through it. So PJ of T, so at any given time T, is the probability or the fraction of confirmed COVID cases. So we still had a COVID model because we have outbreaks every October that are going to arrive to Unit J at IU Health. This is the transfer probabilities. So when I finish my stay, let's say at an ICU, this happens a lot with COVID patients actually. They start in a med surge, they get really sick, they go to an ICU, they recover a bit, they go back to a med surge, and then they leave. Right? Hopefully they leave having recovered. So this is a transfer probability. It's a very classic queuing model. Right? Come in, stay here for some period of time, then I transfer to another unit, and then I leave. It's like my dissertation. Old stuff. Okay, we have a service rate. How long do they stay? That was the interesting thing about COVID. When we first started trying to forecast COVID stuff, most of the COVID patients were still in the hospital. So we had no idea what length of stay was for a COVID patient. Just absolutely no idea. So, and we've got the number of patients that are currently in a particular unit. When I talk about unit, for IU Health, the most important thing was acuity. So ICU, PCU, or med-surg, because they have different nursing ratios. So in the ICU, you need one nurse for every 2 patients. PCU, it's 1 for every 3. And med-surg, it's 1 for every 4, but it's really 5. Everyone says like the ratio should be 1 to 4 in med-surg, but it never is. At least not in Indiana. My wife says, if I get 5 patients, that's a good day. Okay? So here's the formula. I know you guys in engineering like formulas, so number of patients in Unit J tomorrow is the number in that were here today that did not leave, plus the new arrivals, plus the people that transferred from another unit to this unit. And that's it. Literally all we did was took some data. We used this as our like very, very basic model. We took some data to estimate these lengths of stay, these arrival probabilities, these transfer probabilities. And yeah, we did some tuning and stuff like that to try to get it to forecast well, but it worked pretty decently. It's nothing fancy. We're getting more fancy because we need to publish a paper. Also, we have another reason to get more fancy. But. Okay, so how did it work during COVID? The testing is in red. There's the training. This is actually the first month and a half or so of COVID. So, as you can see, our model was actually not that bad. Our mean absolute percent error was about 8 to 9%, depending on if we're talking about ICU or med-surg. Here was the state of Indiana's model. It was like 40%, because they're like, we're not going to use your model unless you show us you can beat the model that the state gave us. And I was like, oh, I would love to. Let's see. A flu model from 2006. in Excel versus my model in Excel. Yeah, so the problem with the state model also is that it was following a predetermined trajectory of the flu. And so it was actually, the bias was getting ridiculous because it was assuming COVID was going down and COVID was actually going up. So that's what convinced him to actually move forward. So what do we need to do? Well, we thought about this a number of ways, right? We started with the way we know, right? If I can predict how many are going to arrive, how long they're going to stay, what's the probability they're going to transfer, I can figure out how many patients there are. It's just a structural approach to figuring out patient flow. Going forward, we actually found that there's a better way to do it. And that's important for future work that we've got going on, not just theoretically, but practically. Okay? So here's some stuff we tried. For the COVID patients, we use an adaptive SIR model that I just optimized some parameters to minimize the squared error, essentially. Then we had like an LSTM for emergency arrivals and a neural net for electives. Part of the reason is because we had access to their surgical schedule, so it kind of helped. But it's surprising, like even if you know what their surgical schedule is going to be, it's surprising how difficult it still is to predict how many people are actually going to show up. For discharges, we tried a bunch of different methods. Eventually, we landed on the random forest approach. Okay. And then we have all those inputs, and we just run our little fluid model with that set of equations, that very simple deterministic equation. And we can get our census. Using our census, we can then turn that into scenarios in a stochastic program. Right? How did it work? Well, I'll just give you a couple examples. This is for non-COVID patients, because at first we were just doing COVID patients, because they kicked all of the non-COVID patients out of the hospital. But then we're like, oh, well, we should probably know something about all the other patients too. So we were off. If you look at that root mean squared error, also the MAE is about the same. That means we're predicting we're off by like one nurse, because a nurse takes on average, 2 to 5 patients. So our average error in MS and ICU was 3 and 4, which means we're predicting 2 within like a nurse that we need, which is kind of good enough. When I teach forecasting, I always tell my students, what kind of error do you need? And they're like, I don't know, you want it to be small. I'm like, yeah, but like, how do you know it's small enough? Well, it depends on the application, right? If I'm predicting well enough to guess within one nurse, that's sufficient, right? Maybe it looks bad because I'm missing 3, 4 patients, but it's only one nurse. So. Okay. Here's the discharge prediction. This one was actually really, really hard. We spent months on this to get that next level of improvement. But we ended up not too bad. Not as easy as the arrivals, surprisingly, because you would think you know something about the patients. They're already in the hospital, right? You know how long they've stayed, all these things. But it was actually harder than the arrivals in terms of we couldn't get quite as good a prediction, but still not bad. Now you may be asking yourself, what happens when I put all these things together into one model, right? You've got errors here, you've got errors there. What's going to happen, right? 2 ways it could go, right? The errors could combine and get worse, or they might just kind of even out. Don't really know, right? I don't have any theory in my head that tells me what the answer is going to be. Turns out when we combined them, it wasn't very bad. It wasn't too bad. It didn't the errors did not cascade and kill the whole thing. Also, the optimization was really robust to misspecification. Okay, so we did all that theoretical stuff. It was fun. The end. Not really, right? Then we had to do the implementation. So a lot of this comes down to visualization. And this is something that I think I missed last couple times I tried to implement stuff in hospitals. And so that partly I'm just going to talk to you about my learnings about how do you get industry to work with you. Found out a lot of it is teaching and visualization. So here's a figure that we created that the nursing staff looked at and they were like, dang, I think we do want to do this. So this is understaffing across the 5 regions. Region 1 is at the top, 2, 3, 4, 5, and that's over the next 14 days on the x-axis, right? And we're like, this is what it's going to look like. This is what it's going to look like if you don't do anything, right? But if you follow our transshipment plan, we project that on the right. That's what it's going to look like. I'll give you a hint. Yellow and white is better. And they're like, wow. They're like, not only do we want to do this, we could even justify doing this because what they have to do when they have to move a nurse, they actually have to call up the hospital and say, hey, by the way, I'm taking your nurse. And, that hospitals do not like that. But they're like, I could show this to, my CNOs at, Bloomington, Indianapolis, Lafayette. And I could say, look, do you feel good about yourself leaving Ball Memorial Hospital in that dark red right there? Because that's what's going to happen if you don't give me a nurse, right? It's such a visual of fairness that they loved it, right? And so we actually ended up building this into the application that they use in like a Power BI application. Because they want to have it. They wanted to say, hey, look, this is where we're going. This is where we are. Work with me. That was a huge part of it. Just get them to work. Not just buy-in from the management, but then buy-in from everyone on down the ladder. Okay. We also had stuff like this, which is another visual. It just says like, here's your basically your utilization before and after, right? You can see it's kind of lumpy in Region 5, and then after it gets smooth. One place that didn't like this very much was Bloomington, because they're overstaffed a lot. So they do it on purpose. So they ended up like having to ship some of their nurses away, and I think my name gets cursed a little bit when my wife's working. They're like, who's that guy that, did that thing that's making us move our nurses around? And my wife's like, oh, I don't know who that is. Okay. So visualization was key. Explaining was key. I remember I was having a beer with the head of Workforce Central Staffing, and I was like trying to find a way to explain to him why we need to do this. And I said, okay, Troy, if you wanted to like do this by hand, what would you do? He'd like, well, I'd kind of look at, the different occupancies, and I'd kind of say, well, this one's usually high, so maybe I'll move some here. And I'm like, do you think that would work really well? He's like, no, it would be terrible. I'm like, what if you tried like 10 different ways to do it? He's like, well, yeah, maybe I could pick a better one. I could find a better one. I'm like, you see this stochastic program? It can try millions of different ways to do it like that. And then the next time he went and talked to the CNE, the chief nursing executive, he was like, look, this thing can try millions of schedules all at once, and it will find the best one. And I was like, wow, he listened. So it's all about education, motivation, and working your way up the ladder. When we first started working with IU Health, someone told us, oh, you're not speaking to the right people, right? And it turns out we weren't at the beginning. But started to get a reputation, and then we moved to a higher level, Now we're working with the CIO and the Associate Chief Nursing Executive, but it took us 2.5 years, right, of dedication and constantly knocking on their door, calling them, setting up meetings that they would sometimes come to, and sometimes they wouldn't. I drove up to Indianapolis a lot because they seemed to actually come if they knew I was driving up there to go meet them. So spent a lot of time driving back and forth from Indianapolis. But now we have a really, really solid thing going. And the nursing org wants to just keep pushing. They're like, oh, now let's do this. Let's do that. Okay, one thing at a time, though. So how did it work? Well, we created this Power BI app. By the way, I got to check my time here. I'm just having fun chatting. Oh, good. I'm okay. And here's how, like, operationally it worked within the system. Every day, they had an automatic query that would pull the historical census. One of the things that was kind of frustrating is we could only get the census from yesterday. We couldn't get real-time. Did you guys know about this, about hospitals? Most hospitals can't get their real-time census. It's fascinating. They're now working with Google Health Engine to try to get up to date within 3 hours census. And they're like really excited about this. But we'd pull the historical census, which was yesterday's census. We'd pull the staffing, pull that all into basically a flat file. Then we have our Python prediction model, which consumes that data, updates the prediction based on the most recent data in here. And the problem is we had like a point estimate. That's what a lot of forecasts do, right? So we had this fluid model. So then we simulated it, essentially. Assumed Poisson arrivals and making assumptions, as we talked about. We made some assumptions, Poisson arrivals and kind of exponential service time. We just simulated it to get what are the different possible paths that could happen in the next 21 days. Then we throw them as scenarios into our stochastic program. We'd optimize it. Then we'd dump that stuff into a file that Power BI could then consume. So every day we were creating 2 things. One, who on the on-call list is actually going to deploy today? And 2, who do you need to call like 2 weeks in advance to let them know that they're on call now? Right. Okay. There it is in all its glory. The problem is I didn't get like the coolest shot because there's other tabs in there where you can see like those heat maps and you can do what if scenarios. They can be like, okay, well, what if I only do 2 nurses instead of 3? But this is what I got a screenshot of. Because I don't know if you knew this, but I don't really have access to just go into their system anytime I want and take screenshots of their stuff. They let me have this one. So this is basically up at the top. We've got, that is who's actually going to go, right? Day 1 is tomorrow, right? Day 2, 3, 4, 5. And it also updates like with what's the probability that a nurse is going to get called in. So that's why we have these updated 2, 3, 4, 5. They only use day 1 to make the decision, but they also let the nurses know, hey, this is your probability as of today that you're probably going to have to go on day 6. Right? Something else they liked. The nurses wanted visibility. They didn't want to feel like they were being yanked around. Right? And then down at the bottom, this tells us how many are coming into each region and how many are going out of each region. And then how many local staff we also have. And then over here, this is our on-call plan. So it tells them how many nurses they need to call and let them know that they're going to maybe be shipping out. We had a lot of tuning parameters in our optimization because they had a lot of criteria for how they wanted. They wanted this program to not just be good for the hospitals, but they were hoping it would also help retain their nurses. Because they're like, well, if they all want to travel, we'll let them travel within our system. We'll pay them a little bit more when they travel. We will make the traveling as pleasant as possible. So we had some tuning parameters that dealt with things like churn. They didn't want too many nurses having to move around the system every day. So they wanted to kind of have like a limit on how many nurses they were actually moving around. So if they move too many around, people are going to get tired of it, right? Like I said, they wanted nurses to be able to have, like, here's the probability that you're going to have to go. Right? They also didn't want to have too many people on call not getting called in. And they didn't want to have too few on call not getting called, right? So they were like, look, we can't just make these on-call lists with like 100 nurses and then call in 2 of them. So they had limits on that too, because they wanted to make sure that their nurses, mostly if nurses were on call, they wanted to go. It was a voluntary program. They would sign up for it, right? So they didn't want to be like, yeah, you're on call, but 10% chance you're going to go, right? So we had these tuning parameters. Basically, we tuned some of the weights in the objective function to achieve some of these strategic goals. Okay. This was our first run at it. I didn't get the colors quite as well on this one, so I don't like this figure, but it's a little bit lighter. But basically, this was when they were having a huge problem up in Northeast Indiana, Ball Memorial Hospital in Muncie. And we actually, our transshipment plan recommended shipping people from Indy and from Lafayette over there. It'd be a 17% improvement in understaffing. There's a lot of weird things that happen, actually, after we implemented this thing. Okay. Now, how do we convince people to actually do it, right? We got management excited, but they were like, so this isn't from me. This is from Mary Drews, who's the Associate Chief Nursing Executive. She's like, nurses are very skeptical about historical data. They do not like it. They don't believe it. So we had to do a lot of things to say, look, we can show you that this is going to do something better. So the first way was we did a counterfactual. We took their historical staffing plan and their historical census, and we ran our model day by day as it would be run in practice. And we said, okay, if you just did exactly what we suggested you do, here's what would happen. Okay? 4% reduction in understaffing. This may seem piddly. It's not. Remember, they have 9,000 nurses, 16 hospitals. 4% accounts to about 300 shifts that were understaffed that wouldn't have been in a year. This is also under really restricted parameters because they said we want to start real small. It's only moving about 2 nurses on average a day. Pretty wild. Misallocation was something else they were concerned about because they hate it when they take these flexible nurses because these are expensive. They're highly skilled, highly trained because they can work anywhere in the hospital, right? They call them the Navy SEALs of nursing. They hate it when they sign them to a unit and that unit ends up overstaffed. They really don't like that because they could have used them somewhere else. So that's called misallocation. Reduce that. So this is historically, right? And they're like, okay, that sounds okay. But how do I know it's going to work in practice? And I'm like, it's counterfactual, right? You guys know about counterfactuals. We all believe them. We're like, hey, the model didn't know that the model didn't cheat. So then they're like, how about we do a dry run? So we basically have been started in October. We started running this every day, making recommendations, comparing our recommendations to what they did. And we did it for about 5 months, right? %. Pretty stable, right? Pretty similar to the counterfactual. The one thing that went down was the misallocation, and that's partly because there was, this was the worst time to run a dry run. Because right after we started running it, Indiana had one of the biggest nursing shortage crises that they've ever had. They had to call in the National Guard to come help staff the hospitals. All the while, my little model is cranking there, and it's you should move people here and there. And then Bloomington opened a new hospital, which means that in the old hospital, they dropped their census to like nothing, so they didn't have to move too many patients, which made my overstaffing numbers look totally weird. But even amidst all this crisis, we're still seeing improvements that are both financially and health status-wise significant. Every time you have an understaffed unit, risks of harm events go way up. Things have happened. I've heard a lot of things that have happened when people are understaffed to patients that are not good, both in the literature and also personally. I hear about stuff. So I think if they take the reins off a little bit and we don't happen to go through two really bizarre events in the system, I think this number gets a lot better. That's what we're working on right now, actually. Things have stabilized. I'm going to go meet with Mary when I get back to Indiana, and we're going to talk about how do we take these numbers and then go convince people, because that's what she's been doing recently, is going around to the different hospitals and selling this thing, trying to convince them that we are going to do this. I know she's actually their boss, but the way things work, she actually still has to. They've got 16 hospitals, but they've been acquired over time, so a lot of the hospitals still think of themselves as hey, I'm just me. I don't have to do what you say. Bloomington is one of those. They're like, we're not IU Health, we're Bloomington Hospital. I'm like, you've been IU Health for 10 years. Come on now. But so she's selling it, and we are working together to design the implementation, the operationalizing of it. Who do you call, right? So now I say I need 2 nurses. Which ones do I call? How long do they stay? That's the other thing, right? In the optimization, which is different than transshipment, is that you send a nurse somewhere, they can't just come back in the same day. It's not safe, right? So you send a nurse somewhere, they have to stay for 2, 3, 4 days, depends on how far they travel, and then they have to return. So it's not perishable inventory. It's not like inventory that I sell. It stays in the system. Which made the stochastic program a little bit more interesting, but certainly not OR worthy. I don't ever expect to send this to OR unless Pangi comes up with something really smart. What's next? This is what's going to get it into OR. We have some issues. So, like I said, that model worked pretty well, but we're forecasting at the hospital level, right? Mary wants to now do it. She wants to start thinking about how can we do it at the unit level. So, they've got these float nurses within the hospital, and sometimes, they don't need them. Where should I put them? Should I move them over here, over there? And if I move them over there, is it going to be okay? You need to forecast the demand, right? Demetrius Bertsimas has a pretty neat paper along these lines. I'm hoping, I've read it. It's not the same thing as what we're trying to do, but it's pretty cool. And so, but you need a lot better forecasts to be able to do that. It's much harder to forecast like a unit of 20 patients than it is a hospital of 400, right? So we have a couple issues. One, in our optimization, we've got something a little bit off, because when we do a traditional stochastic program, we assume that we actually know the entire information when we make that deployment decision. But we don't. We only know census from 2 days ago. And then when Google Health gets in, it'll be 1 day ago, right? So we've got to do some kind of nested optimization where our model looks much more like the real decision-making process, right? So I make my deployment decision with a forecast of tomorrow's census instead of knowing the exact number, right? So we're working on that optimization component. Hopefully that gets it to a level where we could send it to OR. Then we also have another problem. So all our machine learning or forecasting stuff, it's really just giving point estimates, and we have to simulate it. That seems kind of like putting things together in it's pretty heuristic, right? What we'd like to do is we'd like to have a forecast that actually doesn't just give us the point estimate, but really gives us that rich variability and ability to generate scenarios directly for our stochastic So we're working on some generative modeling using a VA framework. Okay? And then 3, we can't handle that many sample paths, right? If we're looking out 21 days, how can I cover that like rich space? 21 days of 16 hospitals of occupancy. Right now we can only do about, I think we max out at like 1,000 sample paths for 21 by 16 observations. No, 21 by 16 by 3 observations. So we're looking at some ways to partition the multivariate Gaussian that comes out of the generative model. So we have this generative model that gives us a Gaussian for each day. And there are certain ways that you can set some cutting planes on those Gaussian variables where basically in some of our testing, we could do maybe 3-4 cuts per day and get pretty high accuracy in terms of estimating understaffing. Instead of like trying to just simulate everything and throw it in there, it won't work. Okay. So that's where we're at. I will wrap here. Actually, let me show you my final slide. I'm going to scroll down a little bit. Oops. Is that me? Yeah, let's wrap here. Okay, so you recall, travel nursing is making it real hard on hospitals. Plus this. So Mary Drews was telling me nurses are even today quitting because they have PTSD from COVID. You know, they hung on, and she said still, like we get tons of nurses like every week that are just like, you know what, I'm just burnt out. I thought I could do it, I can't, I'm gone. Nursing crisis is getting so scary that I think in 10 years we're going to be nationally 500,000 nurses short. This is an old slide. I just recently talked to Mary, and they've been as bad as 40% vacant, which means that 40% of the nurses they need to care for patients they don't have. You got to get smart, right? Hospitals waking up, realizing that if I just don't have the resources, I got to get smart about how I use them. That's kind of the lesson that we're learning here. We're learning it together with IU Health, learning how to work together, learning how to convince them that they need to do something, and we academics know something about how to do it. So, Peng-Yi and I have been collaborators for about 8-9 years now, and we have kind of come up with this philosophy of research. Take theory, good collaboration, practice-driven solutions. Okay? That's IU Health, that's Krannert, and that's math. So, that's all. Thank you for having me here. I really enjoyed a chance to get to speak with you all. And let me put a little plug. 2024. So I'm the co-director for the Center for the Business of Life Sciences at Kelley. We're going to try to take this concept and put our money where our mouth is. So if you see this coming out, and it'll be a little bit, but in 2024 we're going to host a conference in Indianapolis where we're going to have the FDA, we're going to have pharmaceutical companies, we're going to want to have healthcare executives, and we're going to have academics. And we're going to try to get us all in the same room and talk about how we can solve problems together and change the future of life sciences. So, thank you very much. Too much math? Cool. All right.
And I really appreciate this sort of philosophy that you come to. I guess, like
Well, I'd say that they kind of approached me, but we were actually in research discussions because of... Yeah. So, right, that was actually way different. We were going to look at some other nursing stuff. But I actually got connected because of the Center for the Business of Life Sciences. So we basically have this industry outreach program where we try to go and connect faculty with industry folks. And one of the, Troy Tinsley, who was the head of Workforce Central, was a graduate of our MBA program and had a certificate from our center. And so we got basically put me in touch with Troy, and he was like, oh yeah, he's like, I love data, I love analytics, let's talk. So, I mean, I think a lot of times you can leverage connections that larger groups within the university have. That's really how we've been most successful. We've also got another project with IU Health evaluating health IT implementations and its impact on patient care that one of our other faculty is doing. And we're starting up a program with the Ministry of Health in Botswana. All of these came through connections that either the center or the business school or the university had. And I think it's just finding the right person to reach out for you. I used to try to do it myself, and I was not very successful. So if you find someone who knows someone, well, alumni are very great ways to get an in. So it's kind of, yeah. We did once. You would think so. We tried once for some smaller seed funding from a state funding organization, and they said, IU Health makes $1 billion, why don't they pay for it? And and IU Health's like, yeah, we're not going to pay for it. But they're like, if it works, we could go sell it together. And I'm like, oh, okay. So I'll take all the risk, and then you can take the glory, or we can share the glory. But we are thinking, we're definitely thinking about how do we go about finding someone who would fund something like this, right? Is it the NSF? I don't know. Is it sciencey enough? I don't know. Is it the NIH? Well, we'd need a MD, I would think, on the platform, or a nurse or something like that. Maybe the chief nursing executive. So we're thinking about that. But what I've realized as I've moved further into this sort of practice-driven research is that you need bigger teams. You think I did all this? I couldn't do all this by myself. And me and Peggy couldn't do it all by herself. We funded students throughout this using our own research budgets. We funded, IU Health funded 2 of our students to do interns there. So to achieve the goals that we want, we need funding. I just don't know where to go about it, but you can tell me about that at lunch, maybe. Yeah.
Any other questions from the audience?
Relevant question with this research probably not too direct. So as I mentioned for the COVID, and then this is definitely a very, on one side, research.
Mm-hmm.
But from your view, how this works, for example, can be related to remote healthcare, or, I think this probably vision that in the future the remote kind of healthcare, or
Talking like telehealth?
kind of promising, or based on your work, or something.
That's very interesting. So telehealth is something that's a little different, right? It's kind of like pooling demand. So you can I'll say one interesting thing that IU Health has done, which is sort of telehealth related, is that for some of their very rural hospitals, they will staff a nurse practitioner. They won't even have an MD on staff, right? And they'll staff a nurse practitioner, and then if there's anything that the nurse practitioner can't handle, they'll have a hospitalist that will Zoom in. But telehealth makes this problem a lot nicer, right? I mean, it's not a problem anymore because you don't need bodies to meet the demand. The one thing about telehealth, however, that would be relevant is that you start doing telehealth and then you start people coming into your hospitals. So you're going to find stuff. The more you check on people, the more you're going to find stuff, right? And if they're getting telehealth through IU Health, they're going to go to an IU Health hospital. That's what IU Health wants, right? They want you in the system. They don't want you to leave the system, right? And so part of that would be, there would be an interesting question of what does that do to your demand at your big hospitals or at your clinics? That's what I would think is like, and then that goes back to something more like COVID, right? Because that would have to be adaptive forecasting. Because you don't know, if I start offering telehealth in this rural region, I don't know how many people are going to like end up coming to my hospitals or my specialists or whatnot. And we've been doing a little something like that with the VA system in Indiana, because they've been opening up rural clinics as part of their mission. And then they open up a clinic, and then all of a sudden their demand to the main hospital spikes. And they're like, whoa, 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 whoa. They're like, we didn't see that coming. So that's kind of how I think the telehealth might fit into this concept. Yeah. Cool. All right. Thank you. Hey, thanks for coming, guys. It's great seeing you again. Oh, thanks.
It's amazing. So they don't like directly like pay for any of the stuff. They just say, oh, like fund the students. I can't believe that.
They funded 2 interns, and we had to fight tooth and nail to get the budget to fund those 2 interns.
Wow.
It's not that they don't want to. It's that like.
Is that